So, hello everyone. Good morning to all of you. I hope that you are all good. So, you all know that our board exam, grade 10 CBSE board exam, it is going to start from 17th Feb. And because of this, we are going to start one revision series. All right. And here we are going to cover all the chapters of physics, chemistry, bio, and mathematics chapter wise in one short video. All right. So if you follow our series, if you follow our videos, so here you can score maximum marks, and it is going to help to revise this whole syllabus of mathematics as well as physics, chemistry, and bio also. So today we are going to start with our first chapter of mathematics, that is real numbers. And this series, it is not going to it is not only for CBSE board. Fine. So it is also going to help ICSE students as well as all the state board students as well. Fine. So all the students, they can watch these videos and they can get help. All the CBSE, ICSE as well as the state board student. Fine. So let me introduce myself. My name is Ajay and I am the math master teacher at sisyaclass, and welcome to our YouTube channel. Fine. So let us start. Fine. So what are the things we are going to see in this video? So first of all, we are going to see about the real numbers and fundamental theorems of arithmetic, prime factorization, rational numbers, and irrational numbers and its properties. And along with this, we are going to also see PYQs, previous year questions. Previous year question that has been asked based on this chapter. All right. So shall we start? So I hope so that you're all, whenever you are watching this video, so please have your notebooks. And please try to solve questions. You can pause. You are having option now. You can pause the video and you can solve the questions first, and then afterwards you can say, you can look into the explanation. All right. And that time it is going to help you. You can what, analyze yourself, that where you are committing mistakes. All right. Fine. So let us find the first topic, that is real numbers, right? Real numbers. So what are real numbers? Real numbers include both, rational as well as irrational numbers. So if you see the whole number system, fine. So whole number system, it is categorized into two parts. Yes, it is categorized into two parts. That is what, real numbers and imaginary numbers, right? Real and imaginary numbers. Real and imaginary. Yeah. Fine. Acha. Imaginary numbers, you will be learning about imaginary numbers in your higher grades when you will go to your grade 11th and 12th. So that time this topic will be introduced, that is imaginary numbers. All right. But right now we are going to deal only with the real numbers. All right. Acha. In real numbers, again this real numbers, it is categorized into two parts. So that is rational and irrational numbers, right? Rational and irrational numbers. All right. Irrational numbers. Fine. Now what are rational numbers? Rational numbers means those numbers which can be written in the form of P by Q. In the form of P by Q, where P and Q has to be integers and Q should not be equal to 0, right? Yes or no? You might have learned these things in your lower grades also. Fine. So P and Q, they has to be integers, and Q should not be equal to 0. Q should not be equal to 0. And what are irrational numbers, beta? Irrational numbers means those numbers which cannot be written in the form of P by Q. They cannot be written in the form of P by Q. Example you can say minus 2. Minus 2, it is a rational number, right? If you see 3, it is a rational number. If you see 2 by 3, it is a rational number, right? If you see 0.5, it is a rational number, right? And if you see 1 by minus 2, these are all the rational numbers. That means rational numbers include all the integers, fractions, and decimals. All right. And if you look into the examples of rational numbers, you can say root 3, root 5, and you can have 1 plus 2 root 3. Yes or no? Fine. So overall, these are all beta irrational numbers. That means we cannot represent them in the form of P by Q. All right. Fine. if you talk about decimal numbers now, so here, okay, so I will give you one little hint, okay, it is given the ICSE, it is not given the CBSE part, all right. If you talk about the decimal numbers, right, decimal number, so decimal numbers here, okay, all right. So decimal numbers, it is categorized now into two parts, right? Decimal numbers, it is categorized into two parts, that is terminating and non-terminating, right? Terminating and non-terminating. And what are terminating? Terminating means, okay, if you are having 1.2, if you are having 2.25, they are all terminating decimal numbers, right? But if you see the non-terminating, again it is categorized into two parts. That is recurring and non-recurring, okay? Recurring and non-recurring, okay, fine. What are recurring? Recurring means if you are having beta 1.33333 dot 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 dot, yes or no? Fine. These are all types of recurring decimal numbers, all right. And non-recurring means if you are having 1.23457, okay, dot 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 dot. That means, okay, sorry. All right, fine. Okay, so fine. So these numbers, okay, so non-recurring, okay, so the numbers which are non-terminating as well as non-recurring, okay, those numbers are also categorized as irrational numbers. Those numbers are also categorized as irrational numbers, all right. Okay, fine. Okay, so these decimal numbers also we are going to see, okay, we are going to have in the category of irrational number itself, okay, all right. I hope that you all got these points, okay, fine. Real numbers, imaginary numbers, rational, irrational, and decimal numbers. Got it? Okay, all right. So shall we move, okay, to the next slide? Just 1 minute, okay, yeah. Yeah, just give me 1 minute, okay, fine. All right, fine. Acha. Now, how the question will be asked, okay? So question they can ask you, okay, in the assertion type, okay, they will give you two statement about the rational numbers, all right, and they will ask that which one is going to be true, okay, or they will give you some numbers and they will ask you whether it is a rational number or whether it is a irrational number, or they can give you some decimal numbers also, and they will based on the decimal number they will ask you whether it is a terminating one, whether it is a non-terminating one, or whether it is a irrational numbers, all right. So you have to have, okay, in your mind you should have these concept, all right, and based on this, okay, the question will be asked in your MCQs as well, okay, beta, all right, fine. So now, okay, acha, shall I give you some examples, okay? Suppose if I'm asking you one question, all right, fine, okay. So if I'm asking you one question, all right, suppose 1.35, what is the 1.35? 1.35, it is having two decimal places, right? Yes or no? It is terminating after 5, yes or no? And that means it is a terminating decimal number. If I'm asking 1.35353535 dot 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 dot, okay, yes or no? So that means it is a recurring decimal number. Recurring decimal numbers means it is going, okay, decimal places, okay, it is going till infinite, yes or no, beta, and that's why it is what? It is a non-terminating decimal number. But if I'm asking you 1.1235126798234 okay, that means there is not a fixed pattern in the decimal places. You are not having a fixed pattern, right? Okay, and this is what going to be categorized as the irrational numbers, okay. So definition is what? Okay, so those decimal numbers which are non-terminating as well as non-recurring, those decimal numbers are what categorized as irrational numbers, all right. Okay, fine. Okay, all right, okay, fine. Fine there, okay, just 1 more minute, all right. All right. Yeah. Okay. Yeah, Pradeep sir, uh, I'm not able to move to the next slide. Can you please see? Yeah, okay, fine, all right. Okay, acha. Now the next is what beta fundamental theorem of arithmetic. What this theorem says? What this theorem says? This theorem says that if you are having any composite number, that composite number can be written as a product of prime numbers. And what about some prime numbers? Prime numbers, they can't be written. Okay, why? Because prime numbers, if you are taking any prime number, 19 is it is a prime number, right? Okay, and if you want to split this prime number 19 as a product of, okay, two prime numbers or more than two prime numbers, okay, it can't be written, right? Why? Because it is having only two factors, that is 1 and the number itself. Okay, fine. So that's why this is not true for a prime number. But other than prime numbers, if you are having any number, okay, fine, 24. So this 24 we can write as a product of prime numbers, right? Yes or no? Okay, correct. Okay, suppose this 24, we can split this 24 as 2 into 12, right? Yes or no? Fine. And 2 is a prime number, and that's why 2, it can't be splitted further. So now we will split our 12. Okay, so 12 can be splitted as beta 3 and 4. Okay, and again 3, it is a prime number. Further, it can't be splitted. Now we will go with 4, and 4 can be splitted as 2 into 2. Okay, so further, okay, that means 24 I can write as 2 into 3 into 2 into 2, right? Yes or no? That means it can be written as what? 2 into 2 into 2 into 3. That means it can be written as 2 to the power 3 into 3. Yes or no? Okay, fine. Yeah, all right. So this is what, okay, this arithmetic, okay, fundamental theorem of arithmetic says that if you are having any composite number, it can be written as a product of two or more than two prime numbers, all right, or as a product of prime numbers. Got it? Achha. Now there is one question. Okay, this is a very interesting question and very important question also. Fine. So many times such question has been asked in board exams. All right. Okay. So here we have to verify. Okay, we have to verify if you are having any number 6 to the power n. Okay, if any number it is written at the as 6 to the power n. So we need to find out whether this number will end with digit 0. Okay, fine. Acha, if any number, if it is ending with a digit 0, suppose if I am having 10, or if I am having 50, if I am having 150, if I am having 500, yes or no? Okay, or if I am having 170, okay, if I am having 320, any number which is ending with digit 0, can you see? Definitely it is going to be divisible by 5. Yes or no? Definitely. Yes or no, beta? Why? Because 5, it is going to be one of their factor. 5, it is going to be one of their factor. Understood? And that's why any number ending with 0, that is going to be definitely divisible by 5. And if you look in 6, okay, beta? So 6 can be written as what? If you want to write 6, so it can be written as what, dear? 2 into 3, right? Yeah. Okay, so power n, all right. And now if I want to distribute this power, it is going to be beta 2 to the power n into 3 to the power n. Yes or no? And we are not having 5 in the factor. That means 2 is a factor. Here, for this number, whatever the number will be formed with 6 to the power n, it is going to have, definitely it is going to have 2 as their factor and 3 as their factor. But they are not going to have 5 as their factor, and since they are not having 5 as their factor, this number, it is not going to end with 0. Yes or no? Yes, understood my point? Yes or no? Okay, this you have to frame in your own language. Understood? Okay, so you have to explain this, you have to write, okay, in the examination hall you have to write this. So any number ending with 0, definitely it is going to be divisible with 5. And here in 6 to the power n, it can be written as 2 into 3 to the power n, and 2, when I am going to distribute this power, it can be written as 2 to the power n and 3 to the power n. That means whatever the number formed with 6 to the power n, it is going to have 2 and 3 as their factors, but 5, it is not going to be in their factors, and that's why the number, whatever the number it is going to be formed with 6 to the power n, it is not going to be okay, it is not going to end with digit 0, all right, okay. In this way you have to frame your language, understood? But the concept is this, understood my point, beta? Yes, all right. Now, one more question we are having, okay. So we need to explain this, that it is a composite number, okay. Yeah, it is a composite number. Acha, do you know one thing? If we are adding two prime numbers, whether it is going to be a composite number always or a prime number. Sir, if I am adding 5 and 11, 5 and 7, 5 is a prime number, 7 is a prime number, and it is going to be 12, and 12 is a prime number, 12 is a composite number, sorry, okay. But 2 and 3, 2 is a prime number, 3 is a prime number, when you add it is going to be 5, and 5 is also a prime number, yes or no? That means this statement is not always true. Adding two prime numbers, it may give you composite number as well as prime number, okay. But if you are adding two composite numbers, if you are adding any two composite numbers, beta, it is always going to give you composite number itself. Understood my point? Okay. So the same concept we are going to use here, okay. So here our first number, it is given, beta, 7 into 11 into 13 plus 13, okay. 7 into 11 into 13 plus 13, all right. Acha. Now here, if I am going to take 13 common, beta, 13 if I am going to take common, so what I am going to left with? I am going to left with the 7 into 11 plus 1, yes or no? And it is going to be, beta, 13 into 78, right? Okay, it is going to be 77 plus 1, and it is going to be, beta, 13 into 78, right? Yes, okay. Now, whatever the number you will get now, it is going to be divisible with 13 and 78 as well, okay, as well as by all the factors of 78, okay. But here what I am saying, that whatever number you will get, it is going to be at least divisible with 13. 13 it is a prime number, okay, and that's why it is a what? It is a composite number. It is a composite number. Yes, yeah, okay, it is a composite number. All right, acha. Now second number. What is my second number, beta? My second number is what? 7 into 6 into 5 into 4 into 3 into 2 into 1. Yes or no? Into 1 plus 5. Okay, yeah, 5 plus 5. This number we need to tell whether it is a composite number or not. Okay, whether it is a composite number or not, and why it is a composite number. Why? Okay, acha. So here we are having 5 and 5. Can you see here? 5 and 5 we are having. So can we take 5 as a common? Yes, we can take 5 as a common. Okay, take 5 as a common. Take 5 as a common. Okay, so what you will left with? You will left with, beta, 7 into 6 into 4 into 3 into 2 into 1 plus 1, right? Okay, that means whatever the number you will get, that is going to be surely divisible with 5. Yes or no? And what is the definition of prime numbers? Prime numbers means it is going to have only two factors, 1 and the number itself. Prime numbers means if this has to be prime number, if this number, okay, whatever the number is formed here, whatever the number you will form here, if it has to be a prime number, that means it should have only two factors, that is 1 and the number itself. But since here we are getting at least one more factor, that is 5. We are getting at least one factor, that is 5, and that's why it is not going to be a prime number, it is going to be composite number. All right, okay, it is going to be a composite number. Understood? I hope that you all have understood this concept as well as this question. Very important question. All right, okay. Now we are going to see about prime factorization. What is prime factorization? Acha. In the lower grades you have learnt about factorization, right? What is factorization? Factorization means writing any number as a product of its factor. Writing any number as a product of its factors. What is prime factorization? Prime factorization means writing any number as a product of its prime numbers. Getting my point? Prime factorization means writing any number or expressing any number as a product of its prime numbers only. Okay, all right. Sir, can you give me one example? Yes, definitely you will get one example. Suppose if I am having one number, okay. Suppose if I am having any number 960. Suppose if I am having dear 960, okay. I want to prime factorize this 960. What I will do, beta? Okay. So either first I can split, right? I can split it as two parts, that is 96 into 10. Yes. Further can be split our 96. Yes, further we can split 96. Sir, how we can split 96? Okay. You can split in many ways. Okay. Either you can write 3 into 32. You can write 3 into 32, you can write 4 into 24, yes or no? You can write 12 into 8, whatever you can write, okay? But you need to split until you are getting a prime numbers at the end, all right? Okay, so 3 into 32, so 3 is a prime number, so further it can't be splitted, okay? So 3, we will stop at 3, okay? Now further we are going to split our 32, okay? So how we can split our 32? So 32 can be splitted as 8 into 4, yes, it can be splitted as 8 into 4, and further 8 can be splitted as 4 into 2, and further 4 can be splitted as beta 2 into 2, yes or no? And here also 4 can be splitted as 2 into 2, yes or no? That means this part 96 we have splitted, okay, fine, okay, all right. Now for the 10, so 10 we can write as 5 into 2, and 5 and 2, they both are prime numbers, further we can't split our 5 and 2, okay, all right. So what are the prime numbers we are having, beta? What are the prime numbers we are having here? So 2, here we are having 2, here we are having 2, here we are having 2, all right, and here we are having 3, okay. That means 96 can be written as what? 96, it can be written as 2 to the power 1, 2, 3, 4, 5 and 6, right? It can be written as 2 to the power 6 into, we are having 5 and 3, okay. So we are having 3 into 5, all right, understood? So this is what going to be the prime factorization of 960. There is one more way, okay, that is called beta division method. That is called division method, okay. In division method, what we will do? In division method, we are going to divide 960, okay. Okay, you might have solved, okay, these are questions in your lower grades, okay, in your 6th grade and 7th and 8th, okay, but still the question will be asked in your grade 10 also, fine. So again, this is only just prime factorization, all right, but the question will be asked based on the application of prime factorization, okay. And what are the application of prime factorization? Application of prime factorization means the question will be asked based on HCF and LCM, all right, okay, fine. So okay, so here we can write our 960 and we can divide it, okay, with the prime numbers, all right, okay. So the smallest prime number is what? It is going to be 2, okay. The smallest prime number is 2. So 2 into 4, 8, 16, 200 and 2 into 8, 16 and 0 will be as it is, okay, fine. So 480, okay, all right. Further we can divide with 2, yes, further we can divide with 2, okay. So 2 into 240, all right. And further we can divide it with 2, so it is going to be 120, and further we can divide it with 2 and it is going to be your 60, and further it can be divided with 2 and we are going to get 30, and further when we will divide we are going to get 15, and further when we will divide we are going to get beta 3, and further when we will divide we are going to get 5, yes or no? Fine. So further when we will divide we are going to get 5, all right. Acha. Now the product of these, it is going to be the prime factorization of 960, and can you count here how many 2s you are having? 1, 2, 3, 4, 5, 6, okay. You are having 6 2s, all right. That means 2 to the power 6, you are having 3 and 5, okay. So this is how we are going to prime factorize any given number, okay. So you can follow any way, all right, yeah, okay. Now application of prime factorizations, okay, application. Here we are going to see LCM, all right, LCM and HCF, okay. So you will be given two numbers and you will ask you to find out their LCM and HCF, okay, fine. And okay, so further you are, okay, you will be having application of LCM and HCF also, some formulas are there, okay, based on the LCM and HCF. So questions are, okay, so generally asked question based on the LCM, HCF and the formulas based on the LCM and HCF, all right, okay. Suppose if I am having two numbers, all right. What is LCM? LCM is your lowest common multiple. That means if I am having, okay, if I am having any number 6 and suppose if I am having some 24 or some 27, all right. If I am having two numbers 6 and 27. So what is the meaning of LCM? LCM is your lowest common multiple. That means we need to find out that number which should come in the multiple of 6 also and as well as in the multiple of 27, and that has to be a smallest one. Understood? That means, okay, in 6 many numbers will come in the multiple, right, and in 27 many numbers will come in the multiple of 27, all right, but the number which is going to be common in the multiple of 6 as well as in the multiple of 27, that is going to be our common multiple, and among common multiples we have to choose the least one. All right. And what is the meaning of SCF? SCF is your highest common factor. Suppose if I am having the same number 6 and 27, so we need to find out the factor which is common for 6 as well as for 27. Okay, so factor which is common for 6 and 27, that means that will become as a common factor, and it has to be the highest one. Okay, it has to be highest one. All right. So if you see now, if you see factors of 6 and 27, okay, so we are going to have 1, 2, 3 and 6. Okay, we are going to have 1, 2 and 3 and 6 as the factor of 6, and factor of 27, it is going to be here, it is going to be 1, 3, 9 and 27. All right. So these are going to be factors of 6 and 27, and out of these factors, can you see any common factor? Yes, we can see 1 and 3 as the common factor, and out of 1 and 3, which one is the highest one? The highest one is what? Beta 3, and that's why the SCF is going to be beta. SCF is going to be 3 for 6 and 27. All right. Achha. Now what is, okay, one more definition is given, right? So the product of greatest power of each prime factor. What does it mean? Suppose if I'm having any number, okay, suppose this is my first number. All right, suppose this is my first number. All right, it is written, okay, so I'm just writing some prime factorization of first number. Okay, so it is, suppose this is 2 to the power 3 into 3 to the power 2 into 5 and into 7. All right, okay, fine. All right, suppose this is the prime factorization of my first number, and I'm having one more number, that is my second number. All right, and prime factorization for this, it is going to be 2 to the power 5 into 3 into 7 to the power 2. All right, yeah. So if I need to find out the LCM, if I need to find out beta LCM for these two numbers, okay, my first number and second number. My first number is what? 2 to the power 3 to the power 2 into 5 into 7. All right. Second number is what? 2 to the power 5 into 3 into 7 to the power 2. All right. Now, if I need to find out the LCM, LCM is what, beta? What I am saying, LCM is the product of the greatest power of each prime factor. 2, 3, 5, 7, they are all prime numbers, right? Okay, they are all the factors of this given number. Okay, my first number and second number. All right, acha. So out of this, out of prime number 2, okay, fine. So which one is having the greatest power? Greatest power is 5, right? So that means 2 to the power 5 will come. All right. Out of 3, here we are having the greatest power of my prime factor 3 is, it is what? 3 to the power 2. That means I will get beta 3 to the power 2. Here I am having 5 and here I don't have 5. That means I can write 5 to the power 0. Now I can write 5 to the power 0. Okay. Out of 5 to the power 0 and out of 5 to the power 1, which one is the highest one? Which one is the greatest one? 5 to the power 1, right? Yes or no? That means I will get 5 to the power 1 into, now I am having 7 in and 7 to the power 2. So which one is the highest power of 7? Okay, that is 7 to the power 2. Okay. So the LCM, okay, LCM of these two numbers, it is going to be 2 to the power 5 into 3 to the power 2 into 5 to the power 1 into 7 to the power 2. All right, this is what the going to be the LCM. Now if I want to find out SCF, if I want to find out beta SCF, all right, what I will do? SCF means the smallest power of each prime factor, smallest power. So out of 2 to the power 3 and 2 to the power 5, which one is the smallest power? Which one is the smallest power? 2 to the power 3. So that means I am going to get beta 2 to the power 3. All right. Out of 3 to the power 2 and 3 to the power 1, which is the smallest one? That is 3. Okay. So I will get 3 to the power 1. And out of 5 to the power 1 and 5 to the power 0, which one is the smallest one? That is 5 to the power 0. All right. Yeah. And out of 7 to the power 1 and 7 to the power 1, which one is the smallest one? Beta 7 to the power 1. And this is what going to be my SCF. All right. So if you are having any two numbers, concept, if you are having any two numbers, what you have to do? You have to prime factorize them. All right. And after this, if you are going to find out the LCM, LCM means you have to choose the greatest power of each prime factor. SCF means you have to choose the smallest power of each prime factor. Understood my point? Yes. All right. Okay. All right. Now, formulas. Okay. Yeah. This is one of the important topic. All right. Formula. If you are having two prime numbers, all right. If you are having two prime numbers and if you are going to find out the HCF of those two numbers and if you are going to find out the LCM of those two numbers, definitely it is going to be the product of LCM and HCF, it is going to be equal to the product of the numbers as well. Yes, so take one example. Okay, fine, let us take one example. Okay, so example means, dear, suppose if I am having, okay, suppose if I am having any number, shall I take, okay, 6 and 27 I am taking, okay, 6 and 27, all right. So LCM, SCF of 6 and 27, just now we got that SCF of 6 and 27, it is going to be 3. LCM of 6 and 27, smallest number that can divide, that will be divisible with 6 and 27, that is going to be, I think, 54, right? Yeah, it is going to be 54, okay? You can just find out the LCM of 6 and 27, okay? It is going to be 54, all right? And if you multiply them, beta, it is going to be equal to the product of these two numbers, definitely, okay? Just multiply these two numbers and multiply these two numbers, they are going to be exactly same, all right, okay? And it is going to be true for any two numbers, all right? Acha, fine, okay. And there is one more property, okay? There is one more property of LCM and SCF here, okay? Fine, all right. For LCM, there is one more property, all right? LCM properties, all right. If you are having any two co-prime numbers, when you are having two co-prime numbers, suppose A and B are there, okay? And these two are beta co-prime. These two are your co-prime. The LCM of these two co-prime numbers, it is going to be just equal to their product. Understood? All right. Any two numbers. Suppose 3 and 5. 3 and 5 are co-prime numbers. So what is going to be the LCM? Just product of these two numbers, 3 and 3 into 5. If you are having 8 and 15, 8 and 15 are co-prime numbers. So what is going to be the LCM of 8 and 15? It is just going to be equal to the product of 8 and 15. Okay? All right. Suppose one more property is there, beta, one more property of LCM. If you are having two numbers, so in these two numbers, one number can divide the other number. Suppose you are having beta 221 and you are having 442, all right? Out of 221 and 442, 221 it can divide 442. That means it is a factor of 442. In this case, what is going to be the LCM? The largest number, the biggest number, it is going to be your LCM, okay? So please remember these two properties of LCM, okay? These two are the very important properties, all right? They can be asked in your MCQs, all right? And if this question has been asked in MCQ, so that time you have to solve within 30 seconds, all right? Okay, you are not going to take more than that, all right? And if you remember these two properties, so by seeing itself directly you can mark your answers, all right? Yeah, fine. Now for three numbers, if I want to find out the LCM and SCF of three numbers, so you can, okay, first you can find out the SCF of two numbers. Whatever the SCF you got, again you can take the third number and you can find out the SCF, all right? Example, let me take you one example, that time it is going to be more clear for you. Suppose if I am taking one example, okay, 6, 9 and 24, all right? If I am taking beta 6, 9 and 24, all right? If I need to find out the SCF, of 6, 9 and 24, what I will do beta? First of all, I am going to find out the SCF of first two numbers, all right? First, I am going to find out the SCF of 6 and 9, okay? I am going to find out the SCF of 6 and 9. And we know SCF of 6 and 9, it is going to be 3, yes. Now, what I will do? Now, I am going to find out the SCF of 3, the SCF which I got, and the third number, okay? And the third number, that is 3 and 24, okay? 3 and 24. So what is going to be SCF of 3 and 24 beta? It is going to be 3 itself, all right? Yeah. In this way, we can find out the SCF of 3 numbers, all right? Or more than 3 numbers also, okay? If you want to find out the LCM, again, for the same thing, 6, 9 and 24, if I want to find out the LCM, what I will do? First, I am going to find out the LCM of 6 and 9. You can choose any two numbers. Not only the first two numbers. You can choose any two numbers, all right? You can choose 6 and 24. You can choose 9 and 24. All right, you can choose in this way also. Fine. So 6 and 9, what is going to be LCM? LCM is going to be 18, right? Yes. And now, what is going to be the LCM of the LCM which you got and the third number, that is 24. So LCM of 18 and 24 beta. So it can be, okay, I think, okay, it is going to be 72, all right? 18 into 4 and 24 into 3, yes, okay? So 24, it is going to be LCM. Understood? In this way, you can find out the LCM and SCF of three numbers. But there is one more way, okay? There is one more way to find out the LCM and SCF, all right? So we can use the division method, okay? Directly you will get your LCM and SCF, all right? You know now, you can write all the three numbers. You can write all the three numbers 6, 9 and 24. if you want to find out the LCM, if you want to find out the HCF, okay. So HCF means beta, HCF means it is a factor and common factor, yes or no? That means the number, we need to choose that number which can divide all the three given numbers. Any number, any prime number which can divide 6, 9 and 24. Do you know any such number? 2? No, 2 can't divide. 2 can divide 6 and 24, but it can't divide 9, and that's why I will go with 3, okay. So 3 means 3 into 2, 6, 3 into 3, 9, 3 into 8, 24, okay. Now further, do you know any number which can divide 2, 3 and 8? You don't know any such number, okay, and we are not having any such number which can divide 2, 3 and 8, all right, and that's why this 3 it is going to be my HCF, right? This 3 it is going to be beta my HCF, okay. It is the highest common factor for 6, 9 and 24. If I need to find out the HCF of these three numbers, I am going to further divide, okay. I am going to divide until I get 1 at the end, okay. So I can go with 2, yes, 2 into 1 time 3 and 2 into 4 times, and further I can go with 2, and 2 means 1 will be as it is, 3 will be as it is, 2 into 2, and further I can go with 2, and it is going to be 1 will be as it is, 3 will be as it is, 2 into 1, and further I can go with 3 beta, and 1 will be as it is, 3 into 1, 3 and 1, okay, yes or no? And product of all these factors, okay, product of all these numbers, this is going to be your LCM, okay. So LCM it is going to be beta, LCM it is going to be 3 into 2 into 2 into 2 into 3, right, into 2 into 3, all right. That means it is going to be beta 2 to the power 3 into 3 to the power 2, and it is going to be 8 into 9, that is going to be 72, all right, yes or no? In both the ways you are going to get your answer, okay. So you can prefer any method whichever feels easy for you, all right. Understood my point? Okay, fine. So division method, I think it is going to be more easy for you, all right. Yeah. Acha. Now there is one question, okay, there is one question, all right, and these example questions here, they are the PYQs, okay, they are the PYQs, okay. Don't think that they are just examples, they are PYQs, they have been already asked in your previous exams, all right, dear, fine. So here we have to verify that product of LCM and HCF, it is going to be equal to the product of the number. How we are going to verify? So we are having two numbers, right? We are having two numbers, 26 and we are having 91, all right, yeah. So 26 beta, 26 can be written as what? It can be written as 2 into 13, all right. 91, it can be written as what beta? It can be written as 13 into 7, yes. Okay, you can do the prime factorization for 26 and 91 and you will be getting the same, all right. If I need to find out the LCM, LCM of this means beta, I am going to write the greatest power of each prime factor. So here I don't have 2, okay, so that means I am having to the power 0. Here I don't have 7, that means I am having 7 to the power 0, all right. Now can you find out the LCM? LCM is beta greatest power means beta I am going to have 2 to the power 1, okay. For this, for 2 to the power 1 and 2 to the power 0, which one is the greatest one? 2 to the power 1. For 13 and 13 they are common, okay, 13 to the power 1, 30 to the power 1, and that's why 13 it is going to be common prime factor. And 7 to the power 1, 7 to the power 0, which one is the highest one beta, greatest one? That is 7 to the power 1, all right. So this is what going to be your LCM. This number, whatever you will get, this number it is going to be your LCM, okay. And if you are going to find out the HCF, so what is going to be your HCF beta? HCF means we need to find out the smallest power of each prime factor. So what is going to be smallest powers of each prime factor? 2 to the power 1 and 2 to the power 0. Which one is the smallest one? 2 to the power 0. 13 means it is same. 7 to the power 0, 7 to the power 1. Which one is the smallest one? 7 to the power 0. That means 2 to the power 0 means 1. 13, 7 to the power 0 means 1. That means what is the HCF? HCF is what beta? 13. Yes or no? Yes or no? Now, HCF into LCM, okay? We need to find out the product of HCF into LCM. Got it? Okay. So, see here. What is HCF? HCF is nothing but beta 13. Okay, fine. I have written 13. What is LCM is beta? What is the LCM? LCM is what? 2 into 13 into 7. Yes or no? Fine. Okay, all right. Now can we combine them? Yes. 13 into 2. it is nothing but 27, and 13 into 7, it is nothing but 91, yes or no? And it is nothing but the product of these two numbers, yes or no? So that's why HCF into LCM of any two numbers, it is always going to be equal to the product of the given numbers. All right, dear? Yeah, I hope that you all have got this question. Okay, fine. We need to find out the LCM. Okay, here I am having three numbers. Okay, for three numbers I need to find out the LCM and HCF. All right. Okay, so I prefer to go with the prime factorization. You can go with the long division also. Okay, you can write all the three numbers. You can write all the three numbers and you can find out their LCM and HCF. Okay, fine. But I will prefer to go with the prime factorization. Okay, fine. This method is very easy. You can go and you are going to get the same answer. All right. Okay. So suppose if I am writing the prime factorization of 12. Okay, prime factorization of 12. What is going to be prime factorization of 12? It is going to be 4 into 3. 4 into 3 means it is going to be 2 to the power 2 into 3. All right. Yeah. Okay. 15. What is going to be prime factorization of 15? It is going to be 5 into 3. 5, 3 into 5. All right. Yeah. All right. Now 21. 21 means beta 7 into 3. That means I can write 3 into 7. All right. Yeah. So what is going to be LCM now? LCM. What is going to be LCM? Here I don't have 2 now. So that means 2 to the power 0 I am having. Here also I am having 2 to the power 0. Got it. I don't have here 5 now, so that means I am having 5 to the power 0. Here also I am having 5 to the power 0. Here I don't have 7, so that means I am having 7 to the power 0. I am having 7 to the power 0. All right. Now can we find out? Now can we find out the LCM? Yes, we can go for the LCM now. So LCM means we know that we have to choose the highest power or greatest power of each prime factor. Okay. So out of 2, here we are having 2, right? 2. For 2, which one it is going to be the highest one? Out of 2 now, our prime factor 2, which one is having the highest power? Highest power is 2 to the power 2, right? Okay, in 3, for my 3 prime number, which one is going to be the highest power? So they all are having the same power, that is 1. In 5, which one is having the highest power? We are having highest power of 1. And in 7, what is the highest power? We are having the highest power as 7, and that means 7 to the power 1. So when you multiply this is going to be your LCM beta. When you multiply this, you will get your LCM. All right. So 2 into 2, 4, 4 into 3, 12, and 12 into 5, 60, and 60 into 7, you are going to get beta 422 as the LCM. Okay. Achha. What is going to be SCF beta? SCF is going to be beta greatest, or sorry, okay, smallest power. Now we are going to choose the smallest power of each prime factor. Yes or no? So what is the smallest power beta? In prime factor 2, what is going to be the smallest power? Smallest power is 0, right? 2 to the power 0. Yes, 2 to the power 0. In 3 is having the same power. Now yes or no? That means 3 to the power 1. In 5 we are having smallest power as 0. In 7 also we are having smallest power as 0. Yes or no? That means 2 to the power 0 means 1. Here we are going to have 3, here we are going to have 1, here also we are going to have, that means SCF is going to be beta 3 itself. Understood my point? I hope that this question is clear for you all. Okay. So if you are having any bigger number also, you can go in the same way and you are going to get your answer. All right. Okay. Okay. Now there is one theorem. Okay. Very important theorem. Okay. One of the most important theorem. Okay, fine, for irrational numbers. All right, this is going to be used in your irrational numbers. Okay, yeah. So if p is a prime number, if you are having any prime number, okay, and if p divides a square, okay, if p divides your a square, okay, if you are having any number, suppose if you are having something 12, okay, 12 square, okay, suppose if you are having 12 square, all right. And 12 square, if it is divisible, okay, if it is divisible by any prime number p, then definitely 12 will also be divisible with p. Okay, understood my point? If p is a prime number and if it divides any number a square, okay, which is an integer, okay, any positive integer, all right. So that time that number, it is also going to be divisible with the p. This is what this theorem says, all right, okay. And we have to remember why, because we are going to use this theorem in proving irrational numbers, all right, okay, fine. So in the questions they will ask you, okay, they will ask you some questions like, okay, prove that this number, okay, this root 2, root 3, root 5, root 5, 7, something 5 plus root 3, 5 minus root 3, okay, they will give you some, irrational numbers, and they will ask you to prove that this is a irrational number, all right. How you are going to prove this? We will see one example, okay. So here there is one question, okay, and this is a very pet type question, all right. Here and there it is always going to be asked in your board exams for grade 10, that prove that this is a irrational number, okay. How we are going to prove this? Okay, fine, very, okay, there is a standard way to prove this, okay. So first of all we are going to assume, if this is, okay, real numbers, it is categorized into two parts, right, rational and irrational. If it is not a rational number, then surely it is going to be a rational number, yes or no. Only there are only two possibilities, either a number can be any, if there is any real number, either it can be rational or it can be irrational. Apart from this it can't be anything, okay, all right, yeah. So we need to prove it is irrational. So what I am assuming now that, okay, first of all I am assuming that, let assume that root 2 it is a rational number. Assume that this is a rational number, okay. I am not assuming it is a irrational, I am assuming that it is a irrational number. And if it is a irrational number, that means it can be written in the form of a by b, it can be written as a by b, okay. And what I am assuming that a and b, they are co-prime integers, right, they are co-prime integers, all right dear, yes, they are co-prime integers where b should not be equal to 0, okay, fine, all right. This is my assumption, all right, acha. That means I can say that root 2 into b, it can be equal to a, yes. Now if you are going to take square on both hand side, you will get beta 2b square is equal to a square, yes or no, okay, all right. Now can you see here, we can write b square is equal to a square by 2, okay. And if a square it is divisible by 2, then definitely a will also be divisible by 2, yes or no. That means that a will also be divisible by 2, right. A is divisible by 2, we can say that a is divisible by 2, and if a is divisible by 2, I can assume that a is equal to 2 times of c, yes or no. We can see now, if a is divisible by 2, that means definitely a is going to be a multiple of 2, right, yes or no. A is going to be a multiple of 2, and that's why here I am going to replace my a square with my a with 2c. My a I am going to replace with 2c, and here I am going to get beta 2b square is equal to 4c square, and further I can see beta that b square is going to be 2c square, okay. And here also can you see that b square by 2, it is going to be c square, yes or no. That means b square is divisible by 2, and that means I can say that b is also divisible by 2. I can say now that b is also divisible by 2, right. And if b is divisible by 2, that means I can say that b is going to be beta 2 times of something d, right, yes or no. But here, till here itself, okay, only I need to go till here, okay. So here I got one thing, that a and b, they are having at least one common factor. And that is 2, right. They are having at least one common factor, and that is 2, right. One common factor, and that is 2 beta, and that means a and b are not co-prime, yes or no. That means a and b are not co-prime. Whatever we have assumed, it got contradictory, right. And why it is got contradictory? Why our assumption is wrong? Understood my point? Okay, things got contradictory. Why? Because we have assumed wrong. Whatever we have assumed, that is wrong. It is not rational. It has to be irrational. Okay, fine. So here you need to write some sentences, okay. You need to write some theory part also here, okay. So you can write here like this, okay. Since a and b are having, okay, they are having one more common factor, that means a and b are not co-prime. A and b are not co-prime. They are not beta co-prime, okay. And it is contradictory to our assumption, okay. And it is contradictory to our assumption. It is not co-prime, and it is not, okay, contradictory, right. It is contradictory to our assumption, okay, to our assumption, And why it is contradictory to our assumption? Why? Because our assumption is wrong. Okay, and that's why this root 2, it is not going to be rational. Good, root 2, it has to be beta irrational. All right, it has to be irrational. Understood my point? In this way you have to prove this question. Okay, so whenever you are getting for root 2, or where you are getting for root 5, or you are getting for root 7, any number, okay, root 13, root 19, okay, you can prove in the same way. Okay, all right. Now one more question is there. Okay, so you need to prove that 7 plus root 2, it is an irrational number. All right, so generally this question, whenever they are asking this type of question, they will say that root 2, it is an irrational number. You have to assume that root 2 is an irrational number, and that time it becomes very easy. Okay, but here again you have to go in the same process. You have to follow. What you have to follow? First of all, you will assume that this is a rational number. Okay, 7 plus root 2, it is a rational number, and if it is a rational number, that means it can be written as in the form of a by b, where a and b are co-prime integers. They belong to co-prime integers. All right, and b is not equal to 0. Yes or no? Okay, fine. All right. Now here I can say that root 2, it is going to be equal to what? A by b minus 7, and a by b minus 7 means it can be written as a minus 7 b by b. Yes or no? Yes or no? Fine. And again, if all the a and b, they are what? They are integers. Means it is going to be a rational number, right? Yes or no? Here a minus 7b by b, it is a rational. Why? Because all the a and b are integers. And what is root 2? Root 2 is what? Beta irrational. We have already proved that root 2, root 3, all these are irrationals. Yes or no? And that's why again we reach to a contradictory part, right? Yes or no? One side it is rational and the other side it is irrational. Yes or no? One side it is rational and the other side it is irrational. Okay, again we come to a point of contradictory, right? Yes or no? We come to a point of contradictory. And why this is happening? Why? Because our assumption is wrong. Why? Because our assumption is wrong. Our assumption is wrong. Okay, our assumption is incorrect. Okay, and why it is incorrect? So if it is it is not rational, then there is only one option, that it has to be irrational. Yes or no? There is only one option, that it has to be irrational. Yes or no? Why? Because either a number, it can be a number it can be either rational or irrational. Okay, so if our assumption is wrong, that it is not rational, then there is only one possibility, that it has to be irrational. Understood? In this way we have to prove this question. All right. Okay, now PYQ. Okay, now we are moving to our, okay, so till here we have covered all the topics which is there in your NCERT. Okay, fine. All the theorems, all the topics, all the examples I have covered. Okay, based on the same. Now which type of question has been asked in our previous years, we are going to discuss same. All right. Acha. Now students, those who are feeling that they are weak in math, okay, or they are not having that much confidence in math, okay, they need to go through this whole video. Please practice these questions. All right, and based on the same, okay, it guarantee, all right, I guarantee you that you are going to get some good marks. Okay, fine. If you are, okay, and student, those who are good, okay, those who are already, okay, they have prepared everything, fine, so they can take it as a revision, they can solve this question. All right, so you can pause the video, you can solve by yourself, you can get the answer, and after that you can match whether you got your answer as correct or not. All right, fine, these things you can do, fine, in order to get confidence, right? Okay, so two numbers are there, we need to find out the LCM. How to find out the LCM, sir? They are very big numbers, 850 and 500. No issues. I am going to take my first number 850. I am going to prime factorize it. I can break it now as 85. 85 into 10 I can break, and further 85 can be breaked as 17 and 5. Now 5 into 17. 5 and 17, they both are prime numbers, and further 5 can be breaked as beta 5 into 2, okay. That means our prime factorization is going to be here 2 into 5 square into 17, yes or no? 2, okay, now 2 and we are getting 2 times 5, no? So that means it is going to be 5 square and 17, all right. And 500, for 500, sir, for 500 beta we can write as 5 into 10 into 10, right, yes or no? And further 10 can be written as what beta, 5 into 2, and further 10 can be written as 5 into 2, and that's why the prime factorization is going to be beta 2 square into 5 to the power 3, right? 2 square and 5 to the power 3. So what is going to be LCM? LCM is beta, LCM is highest power we have to choose. Now we have to choose the highest power. So for 2, what is going to be the highest power? Highest power, it is going to be beta 2 to the power 2. It is going to be beta 2 to the power 2. Highest power of 5, it is going to be beta 5 to the power 3, and it is 17, yes or no? So can you multiply? Okay, this option it is not given, all right. So we have to bring in the form of our options, all right. Acha. So they have given something 850 and 50, okay. Acha. Can we write in hundreds, all right. So here if I am taking now 5 square, okay, 5 square, 2 to the power 2 into 5 square into 5 square into 5, all right, into 17. So what we can say? We can say 5 square means 25 and 25 into 4, 100, okay. So I can say 100, now 5 into 100 into 17, and if you multiply, okay, fine, 5 into 100, right? Yeah, 100 into 5 into, okay, so 85 into 100, no? 85 into 100, or I can say 17 into 500, okay, 17 into 500, okay, in this form, okay. So I think B option, it is going to be your correct option, yes, okay. B option will be your correct answer, okay. First we have prime factorize. Now we have to just bring them in the form of our options, all right, beta, okay, fine. Here we have to show that this is a rational number, so this question has been asked in 2022 or 2020, right? Already I said na, so whenever they are asking this type of question, so already they are giving that root 3, it is an irrational number, we have to assume, okay. Already they have simplified the thing, okay. So 5 plus root 3, we have to prove that this is a rational number, so 5 plus 2 root 3. Suppose if it is not rational, right, just assume, okay, suppose this is not rational, so what it is? If it is not rational, then definitely it has to be, if it is not irrational, then definitely it has to be a rational, right, yes or no? Why? Because I told that real numbers can be classified only into two forms, right, rationals and irrationals, okay. If it is not irrational, it is going to be rational, and if it is going to be rational beta, it has to be in the form of A by B. Why? Because all the numbers that can be written in the form of A by B, yes or no? Where A and B are integers, where A and B are co-prime integers, right, are co-prime integers, and B is not equal to 0, okay, fine. So that means 2 root 3, it can be written as what beta? A by B minus 5, A by B minus 5, yes, acha. Now can you take the LCM? When we can take the LCM, it can be written as A minus 5B by B, and this is what beta? 2 root 3, and that means root 3, it is going to be beta A minus 5B by 2B, yes or no? Since all A and B are integers, then definitely this part, it is going to be rational, yes or no? This part, it is going to be rational, this is going to be rational, and they have already given that it is irrational, yes or no? They have already given that this is irrational. Understood my point? All A and B are integers, and that's why when you solve this, okay, their addition, subtraction, multiplication, it is going to be a rational number itself. So this part, our RHS, it is going to be rational number, and it is given that our LHS, it is irrational. That means these two are contradictory, right? That means these two are beta contradictory. And why they are contradictory beta? Why? Because our assumption is wrong. Why? Because our assumption is wrong, and that's why this, it is not rational, it is irrational, right? That's why this is not rational, it is irrational number, okay beta? In this way we have to prove this. Understood my point? Understood my point, everyone? Okay, all right. Acha, One more question, it has been asked in 2024. See this type of question, okay, already we have seen this pattern of question, na? In the example question itself we have seen, okay, that time we have to prove, na, that it is a composite number. Here we have to prove that it is not a prime number. If it is not a prime number, then definitely it is going to be composite number. Yes or no? Same thing, just they have changed the language. Understood my point? Just they have changed the language. This we have to prove that it is not a prime number. If it is not a prime number, prime number means if it has to be prime number, that means it should have only two factors, that is 1 and the number itself. If it is not a prime number, that means there should be at least one extra factor other than 1 and the number itself. This is what the concept we are going to use here, right? And this number, in this number, if I am going to take my 11 common, my 11 common, I will be getting 19 into 23 plus 3, plus 3. All right, I am just taking 11 common, okay, I am just taking 11 common, okay, so that's why I will be getting 19 into 23 plus 3, okay. That means it is going to be 11 into something, okay, you can multiply and see that what you are getting this, okay. And from here we can say that this number is having at least one extra factor, that is 11. Yes or no? We are having at least one extra factor, that is 11, okay. It is having, this number is having at least one factor, is having at least one factor, that is 11, okay. Yes or no? Okay, other than 1 and the number itself, and that's why it could not be prime number. That means it has to be a composite number. And it is not a prime number. In this way we can prove this, okay. All right, fine. Now moving to one more question, 2022, okay. How many factors a prime number has? A prime number, suppose if I am having 5, so how many factors prime number it is going to have? It is going to have only two factors, that is 1 and the number itself. 29, how many factors does 29 has? It is having only two factors, that is 1 and 29. And that means all the prime numbers, they are going to have only two factors, that is going to be 1 and the number itself. All right. Ratio of HCF to the LCM, ratio of HCF to LCM of least composite number and least prime number. What is your least composite number, beta? 1, 2, 3, 4, 5. So 2, it is a prime number, right? 2 is a prime number and it is the least prime number. It is the smallest prime number, no? It is the smallest prime number. 2, it is the smallest prime number. And what is the smallest composite number? 3 is also a prime number. 5 is also prime number. 4, it is the smallest composite number, right? It has, yes or no? It is the smallest composite number. So what is going to be the SCF? So that means I need to find out the SCF of 2 and 4, and I need to find out the LCM of 2 and 4. So what is the SCF of 2 and 4? It is going to be 2, and LCM of 2 and 4 it is going to be 4, and the ratio it is going to be 1 by 2, that is 1:2. Ratio it is going to be 1:2. Are you all getting my point? Right? Yeah, fine. Okay, one more question. SCF, they have given that SCF of 13, 39 and 91, okay. They have given what? They have given that SCF of 39 and 91. It is what, beta? 13. They have given that, LCM we need to find out, okay. We need to find out their LCM, all right. We are having two numbers, that is 39 and 91, yes or no? And just now we have seen one formula, okay, that LCM into SCF of any two given numbers, it is always going to be product of these two numbers. So if SCF, what is the SCF given, beta? SCF it is given 13, LCM I don't know. And what are the numbers we are having? We are having numbers as 39 into 91. So can we simplify this and can we get our answer? That is going to be 39 into 91 divided by 13, beta. So if you know 13 table, it can be simplified, right? 13 into 1 time and 13 into 3 time, okay. And just multiply 3 into 91, okay. So 90 into 3 it is 270, and that's why your answer is going to be 273, that is going to be beta B option, all right. Answer is going to be beta B option, that is 273. One more question beta, if n is any natural number, then 12 to the power n cannot end with digit. How to find out? See here, just you have to go with the prime factorization beta, okay. So here 12 to the power n, so 12 to the power n means beta, it can be written as what? It can be written as 3 into 2 into 2 to the power n. That means it can be written as 3 into 2 to the power 2 to the whole power n. That means it can be written as what beta? 3 to the power n into 2 to the power 2n. Yes or no? What I told, I have taken in the starting itself, I have taken one example that if any number ending with 0, if any number it is ending with 0, then definitely that number it is going to be divisible with 5, and divisible with 5 means they are going to have their 5 as a factor, yes or no? And if this number, see, this number it can't end with what? It can't end with, okay, it can't end with 0, yes or no? It can't end with 0. Why? Because it is not having 5 as their factor or 5 in their prime factor. Understood my point? That's why this number can't end with 0, okay. If you want, you can check, okay, if you are going to take n as 1, n as 2 and n as 3, okay, you can check that it will be getting, okay, 8 as their last end digit and 4 as their end digit and 2 as their end digit, but they are not going to have 0 in their end digit or at their ones place, all right. Yeah, fine. So one more interesting question beta, 2021, very interesting question, okay. It is a very interesting question, and this question they are called, okay, they are called some good questions, all right, where most of the students they make mistakes, all right beta. See here, we need to find out that with what is, okay, this number it is going to end with which digit, all right. So here I am having beta 2 into 5 to the power n plus 6 to the power n, all right. If you have observed one thing beta, 5 to the power 1 it is 5, 5 to the power 2 it is 25, 5 to the power 3 it is 125, okay. Whether you are taking a whole number, whether you are taking a even number or natural number as a power, always it is going to end with 5. 5 to the power n, it is always going to end with beta 5, always it is going to end with 5. In the same, if you are going to take beta 6 to the power 1, it is 6, 6 to the power 2 it is going to be 36, okay. Whenever you are going to take any odd number or even number beta, this number it is always going to end with 6, it is always going to end with 6, okay. So 6 to the power n beta, it is always going to end with 6, and here we are having a plus sign and we are having 2, okay. So 2 into 11 and that means 22, and this number, okay, always this number it is always going to end with 2. Always the digit which you will get at the ones place, it is always going to be beta 2, all right. Yeah. Here it is a number 57 by 300. Which type of number it is, okay, whether it is a non-terminating or non-repeating or terminating decimal expansion up to 2 places or 3 places, or non-terminating but repeated decimal, all right. So we have to choose, okay. So first of all, let's simplify this. Now beta 57 divided by 300 means, can I write as 3 into 100, right? Yes or no? We can write like this. Achha. 57 can we divide with 3? Yes sir, we can divide with 3. We are going to get 19 by 100, and 19 by 100 when you divide you will get beta 0.19, and after that means it is a terminating decimal having 2 decimal places, right? It is a terminating decimal number and having 2 places of decimal, that means option B, it is going to be a correct option, all right. Yes, okay, fine. One more question that has been asked in 2019. LCM of 2 numbers it is given as 9 times their HCF, okay. LCM, what they have given beta, they have given that LCM it is 9 times of their HCF, all right, in the first statement. Now what they have given in the second statement beta, in the second statement they have given now that sum of LCM and HCF is 500. Sum of LCM plus HCF, okay, sum of LCM plus HCF it is given what beta, 500, 500, 500, all right, okay. We need to find out what is going to be HCF, we need to find out what is going to be the HCF of these 2 numbers, all right. Achha. here already in the first statement they have given, right? In the first statement they have given that LCM is 9 times of HCF, right? So can we substitute this value? That is LCM can be substituted as 9 into HCF. Yes, we can substitute, right? Plus HCF, okay, plus HCF. It is given as 500. It is given as 500. All right. Now can we take HCF common? Can we take HCF common? We will get 9 plus 1, and it is going to be beta 500, and HCF it is going to be dear 500 divided by 10, and that is going to be beta 50. Okay. So your HCF of these two given numbers, it is going to be dear 50. Yes or no? Now if you know HCF, okay, once HCF is known, 50. Can you find out the LCM? Yes, we can find out the LCM, that is going to be 9 into 50. Yes or no? Fine. So can we find out what is going to be the product of these two numbers? Yes, we can find out the product of these two numbers also, right? Product of these two numbers, it is going to be, okay, so you will get 450 into 50. Yes or no? You will get the product of these two numbers also. So they can extend the same question, okay? They can extend the same question to one more level, all right? And they can ask that what could be the product of those two given numbers, all right? So please be prepared for these types, all right? Okay, fine. So this is one more type of question. Least number which when divided by 12 and 16 and 24 leaves 7 remainder in this case. Acha, just imagine one thing, okay? Just imagine there is one number, okay? There is one number, fine, okay? This number, it is divisible with 12 also. This number, it is divisible with 13 also, 16 also, and this number, it is also divisible with 24 also, fine. There is one number which when you are dividing with 12, when you are dividing with 16, and when you are dividing with 24, always you are getting 7 as a remainder, okay? Always you are getting 7 as a remainder, okay, fine. So what could be that number? So first of all, let's find out that number now, which could be divisible by 12, 16 and 24, which can be divisible by all the three, that is 12, 16 and 24. What can be that number, beta? What can be that number? So that number, it is going to be the LCM, na beta? That number, it is going to be the LCM of 12, 16 and 24, right? That is going to be the LCM of 12, 16 and 24. Just 1 minute, okay? All right, okay, fine. That number, it is going to be the LCM of 12, 16 and 24. Okay, fine. So what is going to be the LCM of 12, 16 and 24? Either you can find, okay, either you can use the division method or you can use the prime factorization method, okay? So with any method you can go with, okay? So your LCM, it is going to be beta 48, all right? If you know the table, 12 into 4 times, 16 into 3 times and 24 into 2 times, all right? 48, it is going to be your LCM. Okay, fine, sir. If LCM is 48, but that is this 48, it is not the number. 48, it is going to be that number which can be divided by 12 also, 16 also and 24 also. But you need to get 7 as a remainder. So what is going to be that required number? What is going to be that required number? That required number, it is going to be 48 plus 7. Yes or no? That is going to be 55. Now check. 57, 55, if you divide with 12, you will get remainder as 7. So 12 into 4, 48. You will get 7 as a remainder. 16 into 3, 48. Again, you will get 7 as a remainder. 24 into 2, 48. Again, you will get 7 as a remainder. Yes or no? In this way, you can think. All right? Yeah. Okay. One more question asked in 2023. Okay. Fine, beta. See, marks are not given, but the questions, okay, this question, it is asked in 3 marks, all right? So, okay, the option, okay, in the starting, I have taken few questions, na? Fine. Here, this number, these are MCQ questions which has been asked in 1 marker, okay? Asked in 1 marker, 2 marker and 3 marker, all right? So, I am taking all the questions which has been asked in either in 1 mark or 2 marks or 3 mark question, all right, beta? Fine. They are saying that HCF of 65 and 117, it can be expressible in the form of 65 n minus 170. So what is the value of n? Okay, you need to find out. All right. Achha. Okay, what they have given? They have given that HCF of 65 and 117. whatever you will get the HCF now, it can be written, this number can be written as what beta? 65n minus 117. Okay, so first of all, let's find out the HCF of 65 and 117. Okay, so HCF 65. So 65 can be written as what beta? 65 can be written as what beta? 5 into 13. All right, both are prime numbers, right? Both are prime numbers. 117. So 13 into 9. Okay, 13 into 9. This is 117. So 13 into 3 into 3. We can write. Okay, all right. So what is going to be HCF? HCF of 65 and 117 beta. It is going to be the smallest power of each prime factor. Smallest power. So what is going to be the smallest power beta? So here I am having power 1, power 1. Here if I am having beta for power 0. Here also if I am having power 0. Here also I am having power 0. Okay. So smallest power, that is going to be beta 5 to the power 0, 13 to the power 1, 3 to the power 0 and 3 to the power 0. That means it is going to be 13. What is the HCF beta? HCF is 13 for 65 and 117. So that means I can write now. I can say now I can say that 13 is equal to beta 65n minus 117. So 117 plus 13, it is going to be beta 130. 130 is equal to 65n. So n is going to be here 130 divided by 65, and that is going to be beta 2. Okay, so the value of n, it is going to be beta 2. All right, so fine. So there is one more question. Okay, it has been asked in 2 mark question. Okay, in 2 marks. All right, an army contingent of 678 soldiers are there. How many soldiers? 678 soldiers are there. They are marching behind an army band of 36 members. All right, so there are some army members. Okay, these numbers are how much beta? 36. All right, and beside this we are having beta 678 soldiers. So you need to find out that if the 2 groups are to march in the same number of columns, that means they should be arranged in such a way that the number of members in each column, beta, they have to be same. So what is going to be the maximum number of columns they can march? Maximum number of columns. How many maximum columns they can form, so that in each column they are going to have equal members. All right, just you need to find out the GCD. Okay, so these questions. Okay, so whenever, okay, one trick you can remember, whenever they are talking about the maximum, that means just think that here somewhere you need to apply HCF, highest common factor. Okay, fine. So here you can see GCD or HCF. Okay, GCD, it is nothing but the other name of highest common factor. Okay, either you can say GCD, greatest common divisor, or highest common factor. They both are the same thing. Okay, just find out the GCD of 36 and 678 and you will get your answer. Okay, you will get your answer. Fine, just solve it by your own and you will be getting your answer. All right beta. 2015, again this question, again they are very pet type questions. Okay, and they are very easy. All right, so 3 persons are there, they are walking together. Their steps, okay, in one step the first person, he is walking. Okay, the length of his step, it is what beta? 40 centimeter. Second person is, it is what beta? 42 centimeter. The third person is what beta? 45 centimeter. All right, what they are saying, what is going to be the minimum distance each should walk so that each can cover same distance in complete step. That means what they are saying, they are saying that if I am going to multiply this, with 1 or 2 or whatever, fine, either they will walk 1 step, 2 step, 3 step, right? The number of step, it is going to be natural numbers, right? Yes or no? So they should cover what? They should cover the equal distance, right? They should cover the same distance. Yes or no? So with what number I should multiply? 40 or 42 or 45, so that the number which you will get now, they has to be same. This number, it should be same. All right, so what can you say about this? This number, it is nothing but going to be the smallest common multiple, right? Yes or no? Multiple of 40, this number, it is going to be in the multiple of 40 also, in the multiple of 42, as well as in the multiple of 45. Yes or no? That means here we need to find out beta LCM. LCM of what? LCM of 40, 42 and 45. Just find out the LCM of these three numbers, and the LCM of these three numbers, it is going to be that same distance which they will cover. All right, yeah, in the complete steps. Okay beta, all right. One more question it is there beta, it is asked in 2017. All right, largest possible positive integer that divides this, and this, leaving remainder 5, 6 and 7. What does it mean beta? Okay, there is one number, there is one more number 162, there is one more number 259. All right, when I am dividing it with some number, okay, fine, and these numbers are same, okay, when I am dividing it with some number, okay, so suppose this number is A, all right, so that time the remainder I am going to get now beta 5, 6 and 7, okay. When I am dividing, so I am getting these numbers as my remainder. That means if I subtract, 125 minus 5, it is going to be completely divisible. This is what now? When I am dividing 125 with the number, I am getting 5 as a remainder. That means if I subtract remainder, the number which I will get 120, it is going to be completely divisible by A. Okay. In 162, when I am dividing with the same number, I am getting remainder as 6. That means when I will subtract this number, I am going to get 156. 156, it has to be completely divisible with the given number. And 259 beta, when I will subtract 7, this number, it is also has to be completely divisible by A. Yes or no? Then what can you say about A? What can you say about A? That means A is nothing but the beta highest common factor of 120, 156 and 252. Okay. So here what you have to do beta, just you need to find out the HCF. You need to find out the HCF of 120, 156 and 252 and 252. All right, that means whatever the HCF you will get, this is the greatest number. This is the greatest number, yes or no, largest possible integer. So whatever the HCF you will get, that is going to be the greatest number which you will get on dividing 120, 156 and 252. All right, and the same number, with the same number, if you divide 125, 162 and 259, you are going to get 5, 6 and 7 as the remainder. All right, yeah, okay, fine. So here, okay, some important PYQs are there beta, some important PYQs, that is, okay, so you can just go through, okay, these important questions. So already we have seen this question in the example, but these questions already have been asked, okay, in the previous years. All right, fine. So here we have completed our this whole chapter, that is chapter 1. Okay, fine. So please revise this chapter. The important theory, okay, theory part it is very less. All right, and please practice some question based on the same thing. You can see some example question from NCERT, or you can just go through some more previous year questions. All right, okay, and please download our sisyaclass app, and you can just explore our app. Okay, here, yeah, you are going to get many such things which is going to be helpful for your education or for higher grades. All right beta, so please like, share and subscribe our channel, and please give your support, and thank you everyone, thank you, bye bye.